Hey class, I'm John Esler, and welcome to John X Wake Up. This is an image you all have probably seen before. It's the water cycle. 6th grade science taught us the process in which water is introduced, cleaned, and reintegrated into the environment. It starts with precipitation. This is the process in which water falls from the clouds and becomes used and integrated into the earth. This could come across as surface runoff, groundwater, and down the line, it becomes evaporated from oceans, lakes, and streams, or is even transpired from plants, turns into condensation in the clouds, and then repeats the process once again, either by snow, rain, hail, and it loops. What this image does not tell us, though, is what happens when water is artificially polluted and different sediments and chemicals and waste is introduced into this water. Here's my story. This is John Esler the First, my grandpa, my namesake. John attended school at RPI and studied civil engineering. He started off in the New York Highway Association, working on projects, creating roads. But in 1989, he started a company that is located on his shirt, mostly specialized in wastewater treatment, and specifically clarifiers. Here is the house that I grew up going to visit my grandparents. There being my grandpa and my grandma. What you don't see in this picture is that off to the right is a personal clarifier that my grandpa established. Throughout the year, he would operate it by himself, but when grandkids had the privilege to come visit, he would have us use big wooden poles to break up the sludge, to mix around all the sediments, and to stir up the excrement, the waste that was located in these tanks. And from this experience, this process, I learned, against my will, what the process is of taking dirty, contaminated water and making it clean. We started by breaking up the layers that began to compile in the first tank, and from this, water could be distributed to the second, where anaerobic bacteria would eat up and remove the sediments and the contamination. And eventually, with time, this water would be reintegrated into the environment and absorbed by the ground and reintroduced to that water cycle that we know so well. Unfortunately, not everyone has the financial or intellectual ability to have their own personal treatment plants. So this means that wastewater treatment must be done on a large scale level. And this begs a question: what is wastewater treatment and how is it conducted in the United States? There are 4 steps that Chemtech US has laid out that I think is a very helpful way of looking at the different, often complicated processes of wastewater treatment. First is the input. This can be done through sewage lines that are connected in urban areas, or even personal sewage tanks that are drained and brought to larger treatment facilities. This is a contaminated water that has excrements, urine, pardon my French. You may have toilet paper and just other items that are not suitable for reintegration to the environment, let alone consumption. And they begin the primary treatment phase. This treatment phase includes screening, the grit chamber, the sediment tank. It moves on to the secondary treatment phase, which is a lot more technical and uses a lot of chemicals. And this is the activated sludge tanks, that sludge put to use, tertiary treatment, and then the chlorination phase. And finally is the output. This is a helpful diagram, also introduced by Chemtech US, that shows the primary treatment phase of wastewater treatment. First is the influent. This is the input. This is the highly contaminated water that is brought to treatment facilities. It goes through a general screening process, which gets out the big contaminants such as inorganic waste, and also bigger chunks of matter. Then it goes into the grit chamber, and this is where my grandpa comes in. I'll get to that soon. But the grit chamber is where the heavier sediment settles at the bottom, and the less contaminated water, maybe it's more either smaller particles or just more movable waste, that is brought to the sedimentation tank, and then eventually goes to effluent. But this brings us to the secondary treatment phase. You see the word sludge showing up a lot in this area. And sludge, simply put, is a condensation of waste that is present in contaminated water. Again, not to get into specifics, but I think you all can infer about what this means. This is the most complicated and technical phase. This is when oxygen is introduced into the sludge and it activates the bacteria, which is the process in which chemicals are recycled and all the contaminants through different processes are removed. This is far more in depth than the screening or the sedimentation chamber. This is really changing the chemical makeup of the water. It separates out from an atomic level the clean water and the waste. This graph here focuses on the biosolid element, but here it shows the dewatering phase, where water is dehydrated from the biosolids, which are then used in compost, land applications, landfills. There's very natural fertilizers and can be extremely useful for renutriizing grain. And when the biosolids are dewatered, the water then in turn is able to be reintroduced to the environment or used for consumption once again, which sounds gross, but trust me, it is effective and clean as part of the process that these treatments do. And we are able to consume that once again, and it gets reintroduced as into the water cycle. Is the final step of the process. This begs the question, is all water treatment equal? What I showed you here is an idealistic process in which water is taken from contaminated state, brought through a treatment facility, and reintegrated as clean water. The answer is that no, all water treatment is not equal. Around 20 or so institutions in 2022 got together to evaluate wastewater treatment sites' ability to detect and identify diseases present in the water. SARS-CoV-2 is the coronavirus, COVID-19 is the second version of it that had a resurgence in 2022 after the initial epidemic. This graph here, the red dots and the blue dots represent the 48 sites in California that are able to detect the SARS-CoV-2 disease. They're able to do this through different chemical testing and software present at these sites that take the water and identify, evaluate if there are diseases present. What this study found is that 41 of the 48 of these sites are located in urban areas. As you can see, Southern California, like Los Angeles County, Orange County, down to San Diego, and then the Bay Area up here are all the areas in which these sites are centralized. And this means that there's a large majority of the state in the rural, the frontier, the farmland areas that aren't able to be, that their water isn't able to be detected and the same safety measures are not present. In California, as we learned in this class, is on the more advanced side of environmental issues, and therefore it is inferable that the disparity is even greater in other states. It makes sense, as urban areas typically have more infrastructure, there's more population, and therefore a greater amount of people to protect. There's more money flowing in. Generally, big infrastructure initiatives are centered in urban areas, but this doesn't change the fact that there's still a significant part of not only the California but the United States population that is suffering from unclean and unsafe drinking water. There's further inequality present, as a EPA study from 2016 to 2019 found that legal violations of water safety measures are 40% more likely to occur in communities where there's a higher percentage of people of color, which introduces a racial inequality that is seen among many policies in the United States as well. Small systems, as opposed to more urban systems, were responsible for 80% of all violations, which again affirms the study that was done in California. Adds further depth to the issue that people living in rural areas are not receiving the same quality of water that people in urban areas are. And nearly 130 million people in the United States live with drinking water violations. This doesn't necessarily mean that the water will induce disease or create widespread seen effects, but with time, unclean water does compile and can create just bodily issues and suboptimal functions throughout life. The conclusion is that water is a fundamental need. is necessary for survival and therefore should be a top focus as far as infrastructure policy goes. We see that cleanliness is complicated. The ideal step that I laid out includes 8 or so specific components, which requires lots of money to come in, lots of chemical expertise, engineers, and this process is only completed with the necessary funding and support, and has no correlation to the complications that rural areas and lack of funding, lack of support can bring to this. And the hope is that we can advocate for further equality. The NAACP posted a brief in reference to the study found by the EPA in which it proved that communities of people of color are disadvantaged as far as water quality. And they had a very, very clear call that we all should take as well, that especially in this class, as people passionate about environmental issues, that we can advocate to legislators, advocate to policymakers, lobby, and even more applicably, just have conversations at the grassroots level, just to illuminate people into that not all water quality is the same, and that as Americans and as people who are fighting for life, liberty, and the pursuit of happiness, we have the ability to raise that standard and have a base necessity of humanity be equal and functional for all people. And we can create a system where everyone is smiling like this clean water droplet. Here are my works cited, and thank you so much for attending.